Should record it. I almost forgot. Identifying quadratic functions. And again, you guys remember, identification is the easiest of the levels of thinking. Identifying quadratic functions. So, a quadratic function. There are three ways that we're looking for quadratic functions. The first way, the first of the three ways, is we're going to look at their graph. How do you identify from a graph? In a quadratic function, you may have a graph, and you're going to say, yes, that's quadratic, or no, it's not. Well, a quadratic function is non-linear. The graph must be non-linear. What does non-linear mean? Trey? It's not a straight line. In fact, it's a very specific shape. It's not a circle. Do you think you know?
It's a triangle.
You have to be able to go through it 2 times in one line.
It's called a parabola. A parabola is a U shape. It can go up or it could go down. But you guys, the trick is it's not technically a U, because a parabola can't be a V, because that's an absolute value graph. A parabola gets wider. If it opens up to the top, it continuously gets wider and wider and wider forever. If the parabola could also, I'm going to draw it on the same picture, could also open to the bottom, but it's not really an upside down U, because a U starts and stops. A parabola always continuously gets wider, and the longer you draw it, the wider it gets. It's like the St. Louis Arch, right? The St. Louis Arch isn't straight up and down at one point. It slowly curves, right? Like Angry Birds. Angry Birds fly in a parabola. Except the parabola gets wider and wider the further down you get. It never stops. So if you're looking at a graph, if it looks like this, it's a quadratic function. It's non-linear. It's in the shape of a parabola. It's this U shape. It can either go up or it can go down. If we have an equation, you could say, yes, it's a quadratic function, or no, it's not. Just from an equation. When we identified polynomials, who was it who said? When we identified polynomials, quadratic meant what? What 2? An exponent of 2. An equation, in order for it to be quadratic, the largest exponent is 2. The largest exponent is 2. It's coming. If you look at the equation and the biggest exponent in the problem is a 2, sure, yep, it's a quadratic function. For example, y equals 3x squared minus 4x plus 8. Is that equation quadratic?
Yes.
Yeah. And I know it's quadratic because the biggest exponent in the problem is 2. X squared. In fact, you guys, this is called standard form. Standard form is y equals, y is alone, ax squared plus bx plus c. Ax squared plus bx plus c. Y equals. Standard form means it's y equals. Looking at this example up here of y equals 3x squared minus 4x plus 8, what's my a value? What? 3. What's my b value? -4. And what's my c value?
8.
Positive 8. Easy. Can you look at an equation and say yes or no, it's quadratic? What do you look for? An exponent of 2. If it has an exponent of 2, the answer is yes. If it does not have an exponent of 2, the answer is no.
It has an exponent of 2, but it also has an exponent of 3.
Then the largest exponent would be 3, so it is not quadratic, it's cubic.
What's special about quadratic?
It's just what we're learning. You learn them all.
So tomorrow we learn about cubic.
You could. You're not going to. Yet.
Yeah.
Tables. This one I think might be the most confusing of the 3 identifications. It's definitely the most work. Copy this table. In this table, the first ordered pair is 0, 0. The second ordered pair is 1, 1. The third ordered pair is 2, 4. The next ordered pair is 3, 9. The last ordered pair is 4, 6, right? There's a table. 4, 16, sorry. Could it be written in ordered pairs? Yes. So in order to see if it works, we have to see, is the change the same? So to go from 0 to 1, what do? You add 1. Yeah. We have. A lot of the stuff we've already done. From 1 to 2, you add 1. 1 plus 1 is 2. All right? From 2 to 3, you add 1. And from 3 to 4, you add 1. So the change in x is the same. It's constant. We want it to be constant. Perfect. Excellent job. Congratulations. Now let's find our change in y. Are you ready? From 0 to 1,
Plus 1.
plus 1. From 1 to 4, plus 3. From 4 to 9,
Plus 5.
and from 9 to 16.
Plus 7.
Well, that's not constant. But ladies and gentlemen, Hannah, put your phone away. This is quadratic, correct?
Yeah.
And quadratic is not just one change. Quadratic is 2. So I have to not just find the change the first time, I have to find the change 2 times. So let's find the second rate of change. From 1 to 3, plus 2. From 3 to 5,
Plus 2.
and from 5 to 7,
Plus 2.
is the second if the second
This is the second power.
change is constant. Not the first change, because the first change is when the biggest exponent is 1. That's linear. This is quadratic. The exponent for quadratic is 2. So I have to find the change 2 times. If the second change is constant, yes, it's quadratic. If the second change is not constant, what's the answer? No. Because it's an exponent of 2, I have to find 2 changes. Spencer, what was your question?
Well, this might sound dumb, but like, I was thinking of it like, it could be like x to the second power.
Right.
Yeah.
Right, so he's saying x to the second power. X squared is 0. 0 times 0 is 0. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared is 9. And 4 squared is... Now that works if it's easy, right? If it's the parent function, it's the most basic. But if they start adding and subtracting things in there, it gets a little harder to see. But that does work also.
Is it just a coincidence that it happens to be plus 2?
Yeah. Yes, this is not always going to be plus 2. That's just the way it worked for us. All right, so I have some examples for you. Are you ready? Tell me about this problem.
No.
Can you identify this example? Is this function quadratic?
No.
I hear no. Spencer, why no?
Because there's no exponent to the second power.
The large exponent
Yeah.
is 1.
Yeah.
The largest exponent is 1. And the largest exponent should be 2. Easy, right?
Yeah.
Okay, so tell me about this trick question. Y minus 5x squared plus 3x equals 3. If I asked you to identify, I gave you this equation, this function, and I said, is this a quadratic function? Explain. What would you say, Julia? It's not in standard form, but is it quadratic? It is quadratic, yes. The largest exponent is 2. It does not have to be in standard form, but here's what I'm going to tell you. What should you do to it? You need to rewrite it so it's in standard form because it's going to make your life so much easier. Standard form means to get y
Alone.
alone. What am I going to move? I want y to stay still, so what's the first thing I should move?
3x.
All right. How do you move 3x? Zach Madden, will you please move back to your assigned seat? On the left side, I am now left with y minus 5x squared equals,
3 minus 3x.
I'm going to put negative 3x plus 3. Why did I put negative 3x first?
Because it has a minus 1.
Variable should go first, right? Is y alone now?
Nope.
Can I keep going? Add 5x squared. Y equals
2x squared.
Can these be combined?
No.
Those can't be combined because they're not like terms.
5x
5x squared
minus 3x.
minus 3x plus 3.
So really, just put an equal sign after the y, and then just
Change it. The value's changed, right? What's the a value?
Can't remember that it's
5.
Oh yeah.
What's the b value?
3.
Negative 3. And what's the c value?
3.
Positive 3.
Who lives in a pineapple under the sea?
Square pants.
Thank you, D'Angelo.
I don't get it.
Somehow everyone in the classroom would not
All right.
no emotion at all.
The a value so this is why it's so important to put it in standard form. Mason, sit up, please. The a value determines if the parabola, the graph, the a value determines, it tells you if the parabola, P-A-R-A-B-O-L-A, opens up or opens down.
Opens down.
It tells us if it goes up like a U or if it goes down like a frowny face. Like a, wonky looking N.
How does that work?
And here's the info. If A is greater than 0, like 3 or 7,
3 is not great.
meaning if it's positive. If the A value is positive, like 5, it opens up because positive numbers go up on the graph. If the A value is less than 0, like a negative value, -2, -1/2, it opens down because negative numbers go down. So they may give you a function, an equation, and say, does it go up or down? And you can tell because if A is positive, it goes up, and if A is negative, it goes down. So take your graph that you got, You can trim it up so that it fits. You're going to glue it on the left side of your notebook.
I keep eating my left and right.
Are we gonna draw a
A parabola. It's not the Ebola virus. D'Angelo, turn around, please, and glue this down.
It's parabola. Wait, no, how does it?
Parabola.
Parabola. I'm gonna get that mixed up.
Crabola.
Sure.
Kids these days. All right, left side.
Found Mr. Headland's thank you note to his teacher.
He has a favorite teacher.
No.
You Miss Long. You're my favorite teacher.
Thank you. Let's keep working.
Very close.
Okay, here we go. You've got this glued down. You should almost be ready.
We're getting gossip about the other math teachers now.
We are going to find from a graph some information. So once you have this glued down on your desk, or on your desk, on your paper, I want you to plot and I'm going to tell you how to do this an easy way. This is a parabola. You're going to start at 0, 5. And from 0, 5, going both directions to the left and the right, you're going to go out one space and up one space. So 0, 5, then you're going to go out one and up one. Put 2 dots. Then from those 2 dots, you're going to go out one, up 2.
Oh no.
It's okay. Really, all that matters is the 0, 5. The first thing we're going to define, ladies and gentlemen, is the vertex. So this is a parabola, and every parabola has a vertex. And the vertex is defined as the highest or
The lowest.
lowest point. It's not both. It's either or. It's either has a highest point or it has a lowest point. I'm going to say my easy definition of this is where it turns. Right? You know, if you're chugging along, riding on a roller coaster on this parabola, right? Wherever you turn directions, change directions is the vertex. So if I'm looking at this particular parabola, where is the vertex? 0, 5. The vertex is an ordered pair.
Is that all we're gonna do with that graph?
Nope. Then we're also going to find
A low one.
the domain of this parabola. And you guys told me when we were doing our objectives that domain is a fancy word for the x values. And what have I been trying to explain to you about parabolas? Do parabolas, are they the shape of a U?
No.
Or do parabolas, every time you go up a little bit, what happens? Expands, right? No matter how many times you go up, or if it goes down, every level you go down, it gets a little bit wider. And the next time it gets a little bit wider. And the next time it gets a little bit wider, forever. The domain, the x values for every single parabola is negative infinity to positive infinity. Every single time. Every single parabola. Because a parabola
I thought X was sideways.
gets wider and wider and wider and wider and wider and wider and wider. Forever.
That looks
Do
weird.
they ever look
They can.
at each
The range, however, changes for each parabola. Because I know every parabola gets wider and wider and wider forever. But the y values, only one of them goes on forever. One of them stops.
Why?
At this parabola, what's the smallest y number we could ever use? Are there any numbers down here?
No.
No. Any numbers here? What's the smallest y number? 5.
I'm not sure.
5 is the smallest number. What's the biggest number? Infinity. Oops, this
Not
should be...
always 5, is it?
Because it's a number, not an infinity, technically speaking, we have to put a bracket, not a parentheses, but it's okay. I don't worry about that with you guys so much. That's more algebra 2.
Next year. No.
2 years.
Infinity. Good job.
What if the graph was upside down? Like this.
So the domain would be
Does the domain change?
yes. It would when you go positive.
The domain is always negative infinity to positive infinity because it
But-
gets wider forever.
The range.
The range does
Negative.
change. What's the smallest number?
Oh, that's infinity.
Negative infinity.
But the largest
What's
number-
the biggest number?
Negative 2.
Negative 2.
At Angelo Allen. That was so
And the last thing we're going to talk about is parabolas either have a maximum or a minimum. They do not have both. This purple parabola I did has a minimum. It has a bottom number. The minimum is 5. This parabola has a maximum. It has a top. And the maximum is negative 2.